Good morning, friends. Welcome to the last part of our final review. This is part 4. We're going to go over the trig stuff. In part 1, we went over this rational radical graphing stuff, and then part 2, we went over more rational radical graphing exponential stuff, and then part 3, we went over logs and review some of their properties. And so now we're going to go over trig. So basically, the first thing I do for all these kind of problems where we find the exact values is I draw the circle and find where the angle is, and don't look at what trig ratio thingy they're asking for. I just find the angle first. So in this case, how to find the angle when it's greater than 1 or greater than pi or 2 pi or whatever, when it's like a bigger number like this. Just think about sort of how many rounds around the circle will it take, plus how many more would allow us to get to that numerator value. And so 17 pi over 4, a whole round around a circle to the left, right, since it's positive, would be 8 pi over 4, because a circle is 2 pi. So in this case, it would be 8 pi over 4. And another round would be 16 pi over 4. And we're at 16 pi over 4 now. We need to get to 17 pi. And so we're going to go another pi over 4, and that would give us this point here. And that angle is pi over 4. And so you think about the angle now, or not the angle, the measure. So square root of 2 over 2. And so secant is the opposite of cosine. So let's find cosine first, which is square root of 2 over 2. Because we have adjacent over hypotenuse, which is just 1. And then secant is 1 over cosine, which is this, which is equal to 2 over square root of 2. And we're going to rationalize it. So, because we don't want the radical, we don't want the square root on the bottom. So we're going to multiply it, and that's going to give us square root of 2 square root of 2 over 2. 2 cancels out, so we have square root of 2 left. So that was our answer this one. I recorded a video for my friend, where is it, on how to do this. So I'm just going to show this. If it's big, so if it's sine negative 17 over 3, you would draw a circle, and then you know that a circle 360 is 2 pi, and in this case 6 pi over 3 would be a circle, would be a full round. And so in this case, you're moving this way since it's negative. So one circle would be 6 pi over 3, and another time would be 12 pi over 3. But it's asking for 17. So you're at 12 right now. And then you count by 3s. So it's 12. 13, 14, 15, 16, 17. So it would be right here. And it would be 1/2, and then square root of 3 over 2. Yeah. So you go by the circle, moving in the negative direction, and then if you look at half of it and you break it into the number of pieces that the denominator is, and then you count by that number. So for this bottom one, you would draw a circle and then move in the negative direction. So in this case, 2 pi would be 12 pi over 6. So it would be 12, one circle, and then it would be 24, and then you break them into the pieces of the bottom number, so 6. So like, wait. So then you're at 24 pi right now. And you have 25, 26, 27, 28, 29, 30, and then 31, 32, 33, 34, 35. So it would be here, and that's square root of 3 over 2, and then 1/2. And that angle is pi over 6, and the other one was pi over 3. Yeah, okay, so that's how you do that. So I'm going to skip these, hopefully that made sense. And then let's move on to these triangle thingies. So we know this side is 17 because 8, 15, 17 is a very popular right triangle. Popular side angles, side lengths. But if you didn't know that, you would just do 8 squared. Use the Pythagorean theorem, a squared plus b squared equals c squared. C squared being the hypotenuse, so it would be 8 squared plus 15 squared equals c squared. And so that would give you 64 plus 15 squared is 225, and 225 plus 64 is 289, and the square root of 289 is 17. So that's how you do that. And then so secant is the opposite of cosine, so it's always easier to start with either sine, cosine, and tangent when trying to find the reciprocals. So let's start with cosine, which we know is adjacent over hypotenuse, which is, here's our angle, adjacent is here, hypotenuse is here, so 8 over 17. And then secant is 1 over cosine, so 1 over 8 over 17, and that is 17 over 8. And 1 over 8 over 17 is the same as 1 times 17 over 8, which gives us that. Now over here, this is our angle. Sine is opposite over hypotenuse, so it's 5 over 7. Okay, for down here, when converting from degrees to radians, we know that radians has pi in the numerator, and so we want pi to be a part of this, and we need to divide by 180. And so now we're going to solve. So now we have 60 pi over 18, and let's see, 6 goes into 60 10 times, and then 6 goes into 18 3 times. That is your answer. So 600 degrees in radians is 10 pi over 3. So same thing here, you're going to multiply by pi over 180. And 45 goes into 184 times, and 45 goes into 317 7 times. So that is your angle in radians. 0. Okay, so I'll start with this one. So for converting from degrees to radians, you want to get rid of the pi. So pi is going to be on the bottom, and then 180 is going to be on the top. You cancel out that, and 18 goes into 18 once, 18 goes into 180 10 times, so you have 110 degrees, because 11 times 10 is 110. So over here, when I multiply by pi over 180, I just have 0. So 0 radian is 0 degrees, and 11 pi over 18 radian is 110 degrees. Okay, next. So this top section is just the basic shapes of these functions here, or these. Yeah, so first we have cosine theta, and we know that the OG, or like the basic, or the parent function of all cosine transformations, the period is 2 pi, and then we start at the max and we end at the max for the period. So in this case, since there is no, what's it called? There's no, what's it called? It's like there's no, why can't I think of it? What's it called? Oh, there's no amplitude. So it's just going to stay at 1 there, and then halfway through is going to be at the minimum. And we see here there's 4 points, so 1, 2, 3, 4 would be here. And then halfway through these 2 points would be our intercept. So here, 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 and then so this is your graph for cosine. Okay, and next we have cotangent, and let's start with tangent. So let's start with tangent. We know the period is also 2 pi, and it starts at 0, and tan is like there's also, so halfway through, so for like cosine, halfway through is the minimum. Halfway through the period is the minimum. For sine, halfway through is the intercept. And then for tan, halfway through, I guess is also, you can also think of it as another intercept. So in one period of tan, you have 3 intercepts, 3 points. So these are your points. And then halfway through these points, so halfway through each point is a vertical asymptote. Whoa. And then halfway through between this and this is going to be 1. So same thing, there's no amplitude, so it's just at 1. And so this from here to here is actually a straight line, so it's important to make it straight like this and then curve, not touching your asymptote. Something like this would be tan. And then cotangent is where it intercepts. Instead of there being a tan graph or tan line thing, for cotangent, where it intercepts, instead of there being a graph, it's going to be the vertical asymptote. So we know that the period is 2 pi, and there's going to be, usually for tangent, actually always for tangent, there's a point for 2 pi. If there's no transformation or anything, just the parent function, the period is 2 pi, so there would be an intercept, there would be a point there. For cotangent, instead it's going to be a asymptote, vertical asymptote. And this idea relates to a few of the later stuff we'll do. And then where the asymptotes would be for tangent is going to be where our points are. So just halfway, so in between these vertical asymptotes is going to be an intercept for a graph. And it's going to basically do, instead of going up, you're going to go down instead of going, so it's going to do the opposite. So it's going to be going like this instead of like that. It's going to be going like that. Okay, now for cosecant, so we know for sine, the period is 2 pi, and the graph crosses through 0, and then it intercepts at pi. So this is the graph for sine, and the max and the min would just be 1, right? For cosecant, which is the opposite of sine, where it intercepts is going to be the asymptote. So similar to tan for cotangent also, and it's also the same thing for secant. So wherever it intercepts in the parent function is where the vertical asymptote is going to be. And then you're gonna plot basically like these points. You're gonna plot your maxes and your mins, which in this case is just 1. And then your graph is halfway from the asymptote to the point is gonna be, your graph is gonna cross those points. So it's gonna be like this. It's gonna be like this, this, like that. Yeah, and then here I also posted a video on how to do this, but we'll do these now from our practice. You should go back and look at those. Let's just do tangent. In the last videos I posted, I did a lot of cosine and sine examples, and I didn't do too many tangent examples, so I'll do this one right now. This one's kind of tricky. So basically, we're going to set the inside to 0, and then we're going to set it to 2 pi to find the start and the end of our graph. So that's where our graph is starting, and let's find the end of our period. So this is what you have, and so let's find our period also. Cool, so our period is 3 pi, and okay, so let's find these points. So we have a transformation, so this is gonna mean that our graph is going to be shifted up 1, and let's see. So both these points are off the graph, so that doesn't really help us. But we have our period. We know it's 3 pi, which is right here. But it's going to go back pi over 4. So it's going to move back. Okay, so hold on. A better way to think of it is the distance between our starting point and our ending point is this much. Is 9 pi over 2, and we see that's 9 pi over 2, and how long it takes us 1, 2, 3, 4, 5, 6, 7, 8, 9 units is a whole period, and so that means 4.5 units would be where we can plot one of our points, which 4.5, 1, 2, 3, 4, and a half would be here, but we have to move back this much. So we're going to move back to here. So our point's going to be here. And then 4.5 is where I said half of it would be. And then now we need to, like over here, we saw that from the point to the vertical asymptote is another point. So let's find the asymptote first, which is the distance between 2 points. So we have this one right now, and then we know that it's 9 units to make up our period. So 4.5 was how we got this. Half of 4.5 would be 2.25, which is like here. So this here is just 1, 2, and 20. Yeah, so we have this point here, and we have 3 pi, and so half of 3 pi is 1.5, so 3 pi over 2 is half of 3 pi, right? Yeah, wait. Yeah, half of 3 pi is 3 pi over 2, which here we can see is 3 units, 1, 2, 3. And so what I did is I just moved 1, 2, 3. Yeah. That's how I got my asymptotes. And now the distance between this point and the asymptote, we're going to find it, which is like here-ish, and we're going to move up 1/2. Because that is our amplitude. Halfway through these points, move down 1/2. And so we have this graph. Okay, and our graph over here is going to be something like this. Don't know the exact points for sure, but that's how you do that. You know, let's just, let's do this one anyways. Let's do this one also. So we're going to set the inside equal to 0 first, and we get this. That's the starting point. We have a horizontal asymptote. So here, right? And then 1, 2, 3. So amplitude of 3, so I counted up 3, 1, 2, 3. And then let's find our ending point for their period. So 2 theta plus pi over 2 equals 2 pi. Okay. Now where is that? You can see it's 1, 2, 3, 4 is our period. So pi is our period. Okay, pi is our period, you know, because 2 pi over 2 is equal to pi. So you're gonna 1, 2, 3, 4. Find the next points. Halfway through these points is our min. So halfway through is here. And so you want to go to your asymptote, horizontal asymptote, and go down 3. 1, 2, 3. Okay, and halfway through these points is the intersect. So it'll be here. Okay, so the graph is gonna look something like this. So that would be your graph for this. Next, we have solve. So now we're gonna solve these. But instead of, so once we find our general equation, we're basically gonna plug values in and then find which values would fit within this domain that is being given to us. And so I'm gonna do one tan one. You know what, yeah, let me just do them. Okay, so for this first one here, this and this cancel out because moving 1 to the right side would, and then trying to simplify it would make it 3 over 3, and minus 3 plus 3 is 0, so it just cancels out. So now we need to find tan theta equals negative, where it equals negative 3 over 3. So in order for it to equal negative 3 over 3, the opposite has to be 1/2 and adjacent has to be square root of 3 over 2. So let's look at our circle and find where that could be. So it's negative, so it can't be in all students take. It can't be here, and it can't be here. For tan, you just need to use 1 point on the circle. This point here is negative pi over 6. The reason why I'm not using 11 pi over 6 is because it's a bigger number, and if you can make it more easy or simpler for yourself, then why not? So yeah, now we have this, and you want to take that and create your general formula, which is this, negative pi over 6 plus pi n. And if they wanted us to find all solutions, this is what you would put inside the solution set. But in this case, we only need however many. So this is our equation we're going to use to find what points will, or what angle, area, point thingies will lie within our domain. And so first thing I'm going to do is plug in 1 for n, and that would make it plus 6 pi over 6, which is 5 pi over n, which, or not n, 5 pi over 6, which does fit within their domain, meaning it is a solution. And let's try another one. So plus, let's do 2 this time. So it would be 12 pi over 6, and that equals 11 pi over 6. So basically, pi times 2 makes 2 pi, but since we need the denominator to be the same, we're going to multiply 6 to the top and the bottom, so that would give us 6 on the bottom and then 12 on the top. And then when you add, it gives you 11 pi over 6, which is still in our domain. So that would be your answer. And we know that's it because 12 pi over 6 is 2 pi, which can't be a solution, and it's already really close to that point, and it's moving by kind of big intervals, so it won't fit. Like, we could try plugging in 3 and it wouldn't fit. So that's our solution for this. So let's not do another tan one. Let's do a cosine one, and then let's do 60. So for this cosine one, you're going to set the inside to theta, and then I'm going to divide both sides by -8, making it cosine theta equals square root of 3 over 2. And you want to find this point on the circle. And so basically for tangent, you're going to use one angle to find the solutions, but for cosine and sine, you're going to need to use 2 points on the circle. And one way you can find those points is by looking at your circle and knowing that, well, cosine is positive in this case, and so it can't be here, because cosine is negative in this quadrant, and it's also negative in this quadrant. So it can only be these two, and that would be here and here, so pi over 6, and then negative pi over 6. So yeah, now you're going to take this, theta plus 4. So right now we're making our general equation. And you're going to set it equal to one of them. So I'm going to do pi over 6 first, and then you're going to do plus 2 pi n. For cosine and sine, it's plus 2 pi n. For tan, it's plus pi n. Now you solve for theta. Wait, hold on. I am skipping a few steps. Let me like write them out so it's more clear. There we go. We have this now, and now let's plug in the values into pi and see what would give us a solution within this domain. So let's start with 1. So we have negative pi over 6 plus 1, so it would be 2 pi. And then 2 pi would be 12 pi over 6. We need the denominators to be the same in order to add them. That would give us 5 pi over 6, and that is in our domain. Okay, now let's use our next point. So same thing, this inside equal to our angle plus 2 pi n. Pi n, and then now you're going to plug in values. So let's plug in 1, and then you have plus 4 pi over 2, and that equals pi over 2, and that is in our domain. And that should be it, because if you want to figure out the distance between these two, it would be pi over 2 is also equal to 3 pi over 6. And then you have 5 pi over 6. So it moves by intervals of 2, and so like 7 pi over 6 is 7 pi over 6. Oh wait, hold on. Wait, yeah, 7 pi over 6 would not be in your domain. And you can continue testing, but it wouldn't, your answer would fall outside of the domain. So yeah, these are the only two answers that we have in this case. Okay, I'm not gonna do this one. Oh, I'm not gonna do this one. Let's do 60. 60 of these cancel out. And we have, let's set this to theta. Let's go ahead and find that angle. So let's see, sine theta is going to be equal to square root of 3 over 2. And so where can it be? It can't be where sine is negative, so it can't be here, and it can't be here. So it can be here, or it can be here. So let's take this now. We take our theta equal to that angle, which is pi over 3 plus 2 pi n. Oh wait, I should show the steps. I'm gonna keep doing it in my head. Okay, there we go. So let's plug in values now. Let's start with -1, because our solution can't be negative. And this is minus, so we need a positive number to make this positive. And that is a solution. Let's plug it in. Let's try 2 now, which 2 times 2 is 4, 4 over 3, 3 times 3 is 9, and then 4 times 3 is 12. So that's how I'm getting these numbers. And that is a solution also. So let's use the other point. Which is 2 pi over 3. This one here. Oh my god, stop skipping. Okay, so this is what you have now, and now let's plug in -1 again. And that does work. Okay, let's try -2 now. And that works. And so what I like to do with sine is look, since a lot of these worked, I look at the so we don't have to keep plugging. You can look at the values, and you can even write them greatest to biggest, smallest to largest. Then we had 5 pi over 9. And then we had 10 pi over 9. Then we had 11 pi over 9. And you kind of see this pattern, how it moves by. It's plus 4. Or not plus 4. Plus 1, plus 5, plus 1. And that just tells us next is going to be, well, plus 5. And then plus 1. And that's going to be it, because plus 5 would have us at 22, and that is past 2 pi. So that's the solutions for this problem, and that is it for our review for the final. Yeah, good luck everyone. Bye bye.